Welcome back to the bench, everyone. Today we have a Radio Shack HTX-10. This is a 10-meter radio. It's a great little radio. And this particular one, the rotary encoder is not working. We have other ones. Everything else seems to be working except the rotary encoder and the mode works sometimes. So the mode switch, that's going to be a matter of just getting out the alcohol and cleaning all the contacts behind. We'll clean the membrane, the board, and everything. The rotary encoder, not so much. That's going to involve a swap. So let's pull it out and see what we're dealing with. Oh, I'm gonna do that now. Oh, we do have a speaker connector, which is good. Very clean. Still have our dual 1969 finals in there. I don't think this thing has ever been opened or played with. Doesn't appear so. So these the front just clips on, but it has a couple screws on the side here. So we'll get those out. Now we pull the knobs. Sure. Coming off fairly nice, even though they do have glue on them. That was very good. Now we're gonna have to pull the nut on here. The microphone connector. Which I know there's a tool for this. I just don't know what it's called. What I need to search for. If anyone knows, please put it in the comments. Like I've seen pliers, but I've also seen kind of sockets that can go on. This is a bit different because it's got 4 notches in it. But I've seen the ones with it's like a pair of pliers with 2 points on the end, but they're not very strong. Some of these are on pretty tight. That'll probably be one of the next tool purchases. See, now that I've loosened these side bolts, the whole thing is now loose. And this front board is held on with solder, physical solder joints. So once we're finished with this, I'm going to go back and reflow all of those joints once it's all bolted back together. Because I don't like that. Shit, this is not wanting to come off very easily. Side's being stubborn. There she goes. So in that process, you can see here it's floppy. So there's tension on those solder joints. So definitely when it's all back together, I'm gonna get soldering iron in there and reflow all of them, just because something may have cracked during this process. So there's our rotary encoder. It's a little greasy. That is a 4-pin. Just gonna loosen that nut. Not quite loose enough. So I have a feeling that this is going to be a hard encoder to find. But I would really like to find a bunch of these for DDS VFOs, because it's a rotary encoder, but it's got that tactical click feel to it, which I know a number of people seem to complain with CB channel kits or DDS VFOs. If they're old school and they don't like the feel of the encoder, or you're bumping it in your truck and the channel's always moving on it, it's pretty solid. It takes a bit of tension to move it, so if I can source that out, I'll definitely grab a whole whack of them. Problem is, I don't know how easy that's going to be to source. It's probably obsolete. Alright, let's get the solder sucker in there. Okay. There it is for everyone. Don't see a part number on it yet. I see a brand name of SJ. We'll have to pull out the service manual. Appears to be a 6-pin. It's a 6-pin, and then it's got this little board that they're using to adapt it over. So I'll have to look up the data sheet on this and probably find something comparable to it, but we'll check the service manual first, see if there's part number. It's not a Radio Shack part number, and we'll go from there. Okay. Well, you can see here we're in the service manual, and this is what we want. I think that says S3, and it's VP402. VP402. On here, number 42 on this exploded view. Number 42, switch, channel. There we go. Well, I'm having a very hard time finding anything close to this without modifying one of those newer style cheap Chinese ones in. But I don't think this is the problem. The quality of this is too good. I highly doubt it's causing issues. I put my meter up to it, and I am getting some pulses. It's kind of hard to do. I'm just using checking continuity on it, basically, resistance. And I'm getting a resistance when I turn each notch. So what I can do is gently attempt to take this apart and clean all the contacts in it. But upon closer inspection here, if you look at the schematic, it's only showing 3 of the contacts being used, which makes sense because it's on the back of it, or the front of this switch, it has 2 pins that are just directly grounded, and on this little mini breakout board there, it's grounds and that's it. It doesn't do anything else. And then at the back there's 4 pins. The 2 centers are combined with this circuit board. They jump together, so that's your common. And then on the left and right side, that's your up or down. Which correlates to this. The problem is this schematic is scanned and it's horrible. It's missing a lot of stuff here, but as you can tell, it's kind of using it like you would inside a microphone. You're sharing paths. Kind of like a button matrix on a telephone. But what I did notice here, I kind of traced some of the faded lines. We've got the down signal on here goes to the common on a bunch of these switches, yada yada. But it also comes down here, goes through this transistor to the microphone connector, and then in the microphone it's got the up down switch as well. So I'm gonna solder this back on, and I want to check and see, because I didn't try it without the microphone plugged in. The microphone could be causing issues. There could be an issue in the mic if we're lucky, or not. It could also be something to do with one of these transistors here. However, every other button seems to be working. I was having a problem with the mode switch. Mode and tone, so it's this one here that we were having issue with. So these ones are all seem to be tied in. And my up goes. So it could be one of these two transistors here. That's another can of worms there. I can barely read what that says, but we'll have it in the parts list. 412, 411, MQ 411, 412. This cap here could also be shorted to ground, preventing us. So I want to see, one, does the microphone up and down work without this? And I guess I could try that right now the way it is before we do anything. So let's do a little process of elimination here to see what the hell's going on. Okay. Ah. So the mic is working up and down. So another thing we can try for fun is jumping these pins to see if we can make it go up and down this way. We can. Okay. Well, that was easy. So it is the encoder then. So what I'm getting on my multimeter is if I just turn it a little bit, kind of just before it clicks, I get a brief resistance show up. So I don't know if my multimeter's fast enough to catch the pulse. So it could just be that this is really dirty. I'm going to attempt to open it here, and hopefully it doesn't spring out in a million pieces. So let's try that next. Turn the power off on this. And get it out of the way. This could go horribly wrong. I need to bend these two tabs up. There's one. Two. 3. 4. Try to straighten them now. And now this whole piece should slide out, in theory. Oh, this is a good way to stab myself. Just kind of getting the tweezers in there to pry it. Focus is not very good on this, so I might just have to do this off camera, but okay, there we go. I got it in there enough that it's starting to come out. There we go. Oh, and some pins just fell off. So let's put that down before I get too far, because one of these pins fell out. And that's probably where I need to clean. You can see here, that's all that it is. Basically, this plastic gear has indents on it, and it's just basically squeezing these together. As you can see here, tap, 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 tap. And there's one of the pins that came out. One of the contacts. Need more light. Okay, so let's just make sure that's the way everything's supposed to be. Let's see what we have here. Focus. Okay, that piece is falling off now. I don't remember which way it went. And that's our detent spring, I take it. It's all one piece. And it's bent down, so it's clicking on the other side of that plastic gear to give you the detent. Click, click, click. And this is the two pins that were grounded in our circuit, and that's all it seems to be. It's just a kind of ground point. It's got a bit of grease in there. It's holding the grease inside for the shaft. So I'll put a little bit more grease into that before I close it up. I'm going to do this one at a time. I think the best way to do this is with a bit of sandpaper. Now the fact that the up and down wasn't working is possibly that it was the common terminal. I don't see any real corrosion. I'm kind of wondering if it's the grease that got in there, because you look down here, it does look a little corroded or discolored. Nothing's really coming off of this. It's getting a bit shinier. So tiny. Be extra careful with it, not to bend it out of place, but just cleaning it with some IPA. Yeah, it's still not touching the other one. Looks pretty straight. Let's pull this one out. The back of it looks nice and clean and shiny. Let's put it back together. Pardon me. Feels good. Feels good. Ooh, okay. There we go. Yeah, it's clicking nice. Okay, so folded those tabs over. Feels really good. There's no gaps, splits in the mechanism. That shaft doesn't 100% line up with the back plate, but it also doesn't touch or come through that hole at all. There is a gap there. So I'm not too concerned about that. Alright, let's do a little rudimentary test. So I should get a pulse when I turn this. Oh, that's better. If I hold it halfway, I'm getting 0 ohms. Before, I was getting like 0.9 something. Okay. Well, this way. Ooh. 0.1. 0.0. We're better than we were.
JCW, W4 Sierra, November, Tokyo.
And some
24.
DMR while I'm heating up the soldering iron.
I saw that you were on, so I figured I'd stop and sit on it. Hello? From South Florida, near Coral Springs, over.
Okay. So we'll put our little board back on.
Well, if you tried to come back, you didn't make it. Came on and went right back off. So good evening to you anyway. W4JCW, W4SNT.
Okay. Board is back.
HL3BAT, W4SNT. Copy. Not sure what's going on, Bert. Not hearing any audio from you. I did see you key, but not hearing any audio, so I heard some other folks chunking as well. So anyway, we'll just sit back and listen. W4JCW 73. Have a good evening. Okay, I don't understand why you don't copy me, but that's besides the point. I show audio going out. W4SNT, good evening to you.
Okay. We got our switch in.
Yep, 100% that time, Bert. Good evening, 73. 7-3. God bless.
Okay. A little bit tighter. Now for this side. Let's prop the radio up a bit just so you guys can see it. Angle it here. Under that there so we can zoom in. These are these horrible board-to-board jumps that should be ribbon cables. I don't like it. It's a terrible connection that's could break, but it's lasted this many years, and we're replacing it with good lead solder. None of that lead-free garbage. But there's the problem there. I just tried to bulk it up a bit, and now the contacts are all jumping into each other, so the wicket gets them out and start over again. It's kind of hard to do an in-between. You gotta start on one end and work your way down. Because if you try one in between, it's gonna end up jumping the contacts together. There we go. Beautiful. So we'll test this first, but then we'll also come back and reflow all of these ones because we put some stress on it, like I said earlier. But I'm not going to do that until I know we're done in here. Okay. Moment of truth. Hey. Lovely. Now, the other problem we were having was the mode. Is it this one? No. This one. Yeah. Well, it's taking. Yeah, I'm pressing it. Pressing it now a bunch of times. So might have to replace that, but I'm gonna try and clean it first. Put a bit of contact cleaner into that one. There's a lot. Just gonna work it in there. That's all it took. Press, press. Oh, still a little wonky. I wonder if that's even got a bad solder joint. Because it seems to be when I put pressure on the whole thing, it makes a difference. So let's just Take a look there. It's bubbling. Yeah, I think it was a bad solder joint. Now I'm not even putting pressure. I'm just pressing the inner round bit, and it's working. Before, it was intermittent, and if I press the inner and this entire outer bit, it would start working. That's way better. So that kind of scares me a bit. I'm surprised all these peanut bulbs still work. I don't think this radio got very much use. It's never been opened before. Nothing's been touched on it. But see here, there is corrosion going on here, so it might have been stored in a damp place. I'm not seeing it anywhere else. Alright, let's put this faceplate back on. Alright.
Nice. Did you like it? Nice.
Alright, well, let's close this thing up and test it again. There you go. Yeah. There we go. So we're gonna go to 29.300. Audio check, audio, that is sideband. Oh, the button works just great. I'm gonna ground this. Audio check. Audio check, 1, 2, 3. That hums there because I have no ground loop. I have no grounding. I'm just transmitting into the dummy, which I need to bond the ground, and then I'll get rid of that hum. So that's cool. And for fun, we can do a 29.300 megahertz AM. Pull that out. Signal generator on here. Oh, wow. This thing has horrible receive on it, so that's our next step. Our output power is good, but we'll do another video for that. In the meantime, that was the endeavor of fixing our rotary encoder and the button here. So pretty simple, pretty easy, and thanks for watching.